Any rake, it's the actual operation of the machine and its reliability and the ability to get the machine up and running again quickly that are perhaps some of the key features of arguably any machine, but more importantly perhaps hay and grass handling equipment. I think Feller achieves this very well in as much as the cam track is very easy to split out, and each of the rotor stub arms or cam followers are individually mounted in this block, as you can see here. And to remove each element is a very simple operation. Merely removal of these two bolts and the slackening of the adjacent pair will enable the cam follower and the housing arrangement to be removed completely. Very simple, very easy to maintain, and accidents do happen, so should any obstacle be encountered and this becomes damaged, it's very easy, very simple to replace, when maintenance and the ability to get the machine up and running is absolutely paramount. The tine is retained very simply, or the arm, sorry, is retained very simply by a linchpin and an offset plate, and this is one of the key features of this machine. The drive is actually taken, the torsional drive, in other words to bring the tines in and out of work as the machine or the rotor turns. The drive is actually carried entirely by this tongue and this plate, and the pin merely performs the job of retaining the thing as one unit. It's very important to note that the shaft is not drilled and neither is the tube, so we don't have a weak point that can very easily flog out where the pin becomes very loose and the drive becomes very sloppy. And of course, as soon as we drill a piece of tube or a piece of bar, it becomes instantly very weak. So the drive, it is very important to note, as you see there, that the drive is actually carried through this tongue arrangement, and the spigot is merely a method by which we mount the rotor arm itself and lock it in place with a linchpin. Finally, as far as the tines and arms are concerned, as I said, very simple tine retention system and a drive arrangement. It's important to note also we've got a very slight taper here, but it means that these are very simple and easy to repair on farm. It can be sleeved if necessary, or re-welded or straightened out. We're not relying very much on the integrity of this element to form a major part of the machine. And as I said, should we encounter any damage, it's very simple to actually change the cam track housing and the tine arrangement, or repair it on farm. Here we can see the tine attachment to the arm, a thick walled tube for our tine arm, and the tines are attached. The tube is actually punched and tapped, and the tines are actually mounted via this block straight onto the arm. Again, we're not drilling right through the arm, and it's important to note how the tine is swept back, so that should again any obstacle be encountered, the first effect when the tine actually pulls back is to actually lift clear of the crop. So again, very easy and very accommodating, if you wish, of obstacles such as stones and stumps and timber, etc. The operation of the rotor can be determined to provide us with different swath profiles, as I mentioned earlier. This is a rather neat feature with this machine, in that we can adjust the timing basically by advancing or retarding the point at which the tines lift from the ground clear of the crop and then return to the ground to sweep the crop back into the swath again. So depending on the density of the crop, we can either get the tines to drop in earlier or later, or lift out conversely earlier or later. Very simply achieved by advancing or retarding the cam track, which obviously then immediately controls the point at which the cam follower determines the positions of each arm. The cam track, or the timing adjustment, is adjusted very simply by this arm linked to this rod, and it can be positioned as such in 3 holes on the axle, as you can see there. And as you can see, it's actually moving the point at which the tines go into the ground. And all we're doing here is simply advancing or retarding the point at which the tines go into the ground or go into the crop, and at which they come away from the crop. This will have a direct effect on the profile of the swath to give us optimum baling, and I'll come to that in a second when we're working. To the timing that I've just discussed to control the swath profile, we can also very easily adjust the swath width. And you'll notice with this machine we don't have any sliding elements that control the distance of the rotors in relation to each other or in relation to the center of the machine. This is achieved very, very simply by swinging this clevis that we mentioned earlier outwards or inwards to bring the rotors closer or further away, and obviously therefore directly adjusting the swath width that's left. This is controlled by a very simple bar along the top, and it's positioning in one of these 4 holes, as you can see here. So if we move the bar into the outer hole, bell crank arrangement will push the rotor in and in turn reduce the width of the swath. Conversely, if we move it out again, the opposite will occur. A very simple, very simple adjustment, easy to do without any tools. I'll show you in a second. But the important feature here, there is no greased sliding elements that need to be maintained, or conversely will pick up dust and rubbish, etc. And a very simple thing to adjust, and I'll show you that in a second. Here we are again. The black bar that we mentioned earlier has now moved to a vertical position, and you'll notice it's retained in position by this spring. We can now use this as a pendulum effectively and move its position very simply out or in. So swath width at this maximum width at this point, and its minimum width at this point. And obviously due to the changes in geometry, this will change as the machine is unfolded. So as you can see, a very simple, low maintenance, easy to adjust system for altering the swath width. There's one other point that this system enables us to do as well, and that is due to this crank arrangement, as the machine folds up, the rotors automatically drop to their lowest possible position for transport. So that's a feature that this forms part of by reducing the overall height, purely because as the machine folds up, the geometry of this arm and this arm is such that the rotor itself drops to its lowest possible position. And so to the rear of the machine and the carriage assembly, really, the part of the machine which controls the steering and keeps the whole thing, or the main carriage, off the ground, obviously. And you'll notice the machine is supplied with 2 safety chocks, which obviously from a health and safety point of view should always be used, and retained very simply by a spring clip here. And underneath we've got the stowage points for the rotors, which may normally be removed for optimum height reduction for transport. So the steering system, which as I mentioned right at the beginning, was controlled entirely from the A-frame or the headstock on the machine, and as I mentioned, the shaft controlling, or that controls, runs through this beam, and as you can see here, it terminates at a point within this rear carriage assembly. This is bolted directly to this drop arm, and that then to 2 track rods which run out to the wheels on the rear of the machine, and via a very simple kingpin and steering arrangement provide us with our tracking system. So to summarise, the TS671, as I said, the features that I've just illustrated form by and large the features of the other 2 larger rakes in this series, the 801 and the 880. The features with the headstock, the steering, and especially the swath width and profile control are all identical. So very briefly, we've got here a machine that is extremely durable, but very simple to set up and very simple to maintain, and certainly something that should form part of every large hay grass contractors or farmers machinery portfolio.